All right, grade eights. I know you guys are all as excited as I am. It's backwards hat time. We're smooth sailing into the end of the course. 8.6, our last section. We're bringing together the transformations and the tessellations from the last two sections, and we're identifying the transformations that are inside of a tessellation. So the tessellation, again, is any type of pattern that just fills up a space, fills up a plane, either by rotating or reflecting or sliding things over. And so we can actually do that. Here's a simple example. If this is my original shape, I could reflect it to get A. I might even be able to rotate it to get A. I can slide it over to get F. I can slide it a couple over down to get F. I can rotate or reflect it to get G. There's lots of different options here. I can reflect it to get D. Bunch of different possibilities. So we're going to basically look at tessellations and identify what are the transformations that could be used to make that tessellation. Okay. Under each transformation, the area of the shape doesn't change. This is known as the conservation of area. So we're not changing the size of the shapes. That usually never happens in a tessellation. Okay. This means that all the triangles in the tessellation have the same area. That's going back to the previous slide. Okay. Sometimes a tessellation can be described by more than one type of transformation. Okay, so we'll look at, in this simple example, it's kind of got our diamonds here. Let's see if we can identify a translation. So if I take I'll just start with this one in the corner, and that's going to be my original diamond. A translation could just be something being moved over. So I could get to the one beside in just one to the right, and then that would give me this as my new image. I'm just sliding that shape. I could also slide it down, right? This one to this one. I could say 1, 2, 3 down, right? Or 1 to the right, depending how you kind of read the dots. Okay, so that's a translation. There's more, probably you could identify more. Here I could translate, I could slide this one over, right? You can find your own probably fairly easily. Okay, a reflection. So I'll just take a different one. For a reflection, I'll start with this one. This will be my original. So to reflect, I could imagine this is my reflection line and give this shape. So it's just reflecting over that line. I could actually, from that exact same shape, I could do a whole bunch. I could reflect this way, it would give me this one, right? I could actually just reflect on a perfectly straight line this way and give me that one, right? So there's more than one option. There's tons of them in this example. Okay, the last one would be a rotation. So I'll just look at one here. I'll take this as my original shape for the rotation, and I'll take this as my rotation point. So I could actually start spinning this around and get to this new shape here. I could keep rotating it around that space and find a new shape there. A little bit of a tricky one, but you might notice you could actually figure out what angle you have to rotate. This one's a little trickier because I can rotate it again, rotate back 3 times. So kind of going a little bit above and beyond, but if I divide that by 3, I know this is going to be a 120-degree rotation. Normally our rotations are just 90 degrees, 180, 270, right? Just a quarter turn, half turn. This is split into thirds, so it is possible that you could be asked stuff like that on the work in the book or on your worksheets and quizzes. Okay, so those are the kind of the 3 main ones. You can find multiple possibilities throughout these examples. So this one here, hopefully you can kind of see the outline. Notice they've kind of taken a square shape. All they've done is they've cut this out and added it to the other side. So notice that it kind of sticks in there. So identify a combination of transformations. So here, if I take this kind of wonky shape and I start rotating around this point, I can rotate it 90 degrees, give me this shape, another 90 degrees, it's going to give me this one, another 90 degrees, and another 90 degrees. Now, that would kind of just give me, it would kind of complete a kind of a square shape right here. Okay, once I have that whole square, we know that any 4-sided shape will tessellate, so I could just slide it over. I could slide it down and kind of copy the exact same shapes again. Okay, so it's a combination of transformations. We can use rotations. If I look at it from here to here, I can actually just slide this over as well. So it's a transformation as well that could be used. You might use all 3, you might only use one. Depends on the tessellation. So you'll look at a bunch of different ones in this section. How do you know that the area of each shape is conserved? because they all look the exact same size. We haven't changed the sizes of any, don't have any overlaps or gaps, so we know that we have conserved area in this case. Okay, so page 476, your last book assignment for the year. Congratulations.